Okay, welcome to another video made by Mr. Gerard, yours truly. This is for the algebra exit exam. Good luck. Hopefully the quality is a little better. Ms. Andrade and a student helped hook me up. So let's go ahead and get started. I'll show you how I would take it and any shortcuts you could think of, that kind of stuff. If you have questions, talk to your teacher, talk to Mr. Gerard, or Mr. Rossiter, or Miss Youngblood if she sees this, or her students yet. All right. So the test that we're going to be reviewing is this one. Your teacher can get this for you on the Knowledge Center. This is the year 2014-15, and this is the second practice exam. It's pretty much, all these tests are pretty much identical, except this one has recursion, so we're going to skip one of the questions. But short of that, it should be pretty similar to what we're going to see next week. What I'll do is I'll show the questions, and then I'll write on this white piece of paper underneath, just so we can see it a little bit better. Okay. So our first question. Maria is selling cupcakes for $1.65 each. Let C be the number of cupcakes Maria sells. Let S be her sales in dollars. Which equation represents the relationship between C and S? So if this was me and I was taking it, and this is a pretty basic question and pretty easy relative to the rest of the test, but let's think about it for a second. She's selling cupcakes, C, and she's going to sell them for $1.65 each, and S is going to be how much money she makes. If you think about it, if I said, okay, well, she sold 4 cupcakes, well, you would do $1.65 times 4, right? So that's going to be this guy here. Another way to think about it is, if you were stuck, I could eliminate, right? This and this are clearly not great answers. I'm not going to add the amount of cupcakes plus $1.65. So it has to be one of these two. And if you stop and think about it for a second, right, the total amount of money is going to equal $1.65 times cost. So A is your answer. All right, one down. Only 38 to go. Okay, number 2. Okay, this is one of these function questions that algebra teachers really, really love. For several weeks, Teddy really focused his time on studying and saw his math quiz scores slowly improve as he began to understand blah, 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 blah. His scores improved more rapidly. He then stopped studying and his quiz scores no longer improved. Which of the following graphs represents Teddy's quiz scores as a function of time in weeks? So when I look at these, they all have time on the x-axis. Move the guy up a little bit. They'll have time on the x-axis, and they all have his quiz scores on the y-axis. I'll go with green for this. As he began to understand the concepts, his scores improved more rapidly. Okay, so I'm looking for something that starts. The slope's going to increase, right? This part, his scores are slowly improving. As you understand the concepts, the scores improve rapidly. So like starting slowly, improving rapidly, and then he stopped studying and they stopped improving. So to me, it's clearly not, I can eliminate B and C just on the fact that at no point do his scores decrease, right? Because right here, his score is decreasing, and right here, his score is decreasing. And that's never really what happened. Excuse me. At no point does that really start to happen, right? So they said it slowly starts, he starts studying, and then he stops. And this stops, which means there's no change in his quiz scores. So this one has to be A. Like, once again, not so bad. All right, 2 down. Okay, so for number 3, I'm going to write it on a piece of paper just so I have a little space for us to see. Okay, if A equals negative 4t squared plus 5t plus 4, and B equals 9t squared minus 3t plus 5, what is B minus A? So if people make a mistake with this, it's usually just distributing this negative here. So let me show you what I mean. So I'm going to be looking to do b minus a. And b is equal to 9t squared minus 3t plus 5. So that's b. And I'm going to take that and I'm going to subtract a. And a is negative 4t squared plus 5t plus 4. Okay. If it helps to think about it, I really have like a negative 1 here that I have to distribute. So it's going to be like all of this minus negative 4t squared, which is really just like adding. Right, so if I take negative 1 minus 4t squared, that's really like adding 4t squared. Negative 1 minus positive 5t is minus 5t, and negative 1 times this positive 4 is minus 4. So that's what it is, and then they're going to ask us to combine like terms and simplify it. So the way that I do it is I have it all written out like this, and I'm going to start with my larger terms first. So I have like these t squared terms. I'm going to do these. So this is like 9t squared, and then this is plus 4t squared. So I'm going to do 9t squared plus 4t. That's 13t squared. And I like to just kind of cross the stuff off just to keep myself organized as I'm doing it. And then I have the t terms. Negative 3t minus 5t is minus 8t. I'm going to eliminate that also. And that leaves me plus 5 and minus 4. That's plus 1. So I have a 13t squared minus 8t plus 1. So if I go back to this, 13t squared minus 8t plus 1, that's going to be b. Okay. All right, number 4. Which of the following is not a true statement about the graph of the linear equation? 3x plus 5y equals 20. Okay. So I'm going to have 3x plus 5y equals 20. Slope of the line. So I got 4 options. Y-intercept, slope of the line, as the values of x increase, the values of y increase. The line intersects the x-axis at a positive value. So if this was me, and there's lots of ways to do it, you can input values. I would solve this for y and just graph it and go from there. So let's do that first. For a big part of this test, if you're not sure, if you have something in standard form, and there's a lot with like systems of equations, or just graph it. But to graph it, we have to set it equal to y. So to do that, I'm going to start by getting this y by itself. So I'm going to subtract 3x from both sides of my equation. And that gives me this. 5y equals 20 minus 3x. And then my final step is just going to be to divide by whatever this coefficient of y is. So I'm going to divide by 5. And that means I'm going to divide this side by 5 also. So that would give me 1y equals, and this is where the calculator is pretty handy. I'm just going to put this in parentheses in my calculator and divide all of it by 5. Now that I have this, I can graph it. I could also answer like the slope question, right? Because I could think of this really the same way as, right, this is 20 divided by 5, it's just 4, minus 3x divided by 5 is 3/5 x. So this is like the simplified version of this. So if I go back to our question, the slope of the line is negative 3/5. Well, that does look to be true. If I wasn't sure, I could graph that and check to see. So which of the following is not a true statement? So this is a true statement. So I can eliminate this as an answer. So I know it's not B. Let's graph it and see if A, C, or D is correct. So I have a little stack of books here. And I hope you can see this okay. I'll click the ones off. Okay. So I'm going to turn it on. I'm going to go to y equals, and I'm just going to enter my equation, which I should have written out to the side, which was 20 minus 3x, all that divided by 5. So in parentheses, I'm going to do 20 minus 3x, close the parentheses, and divide it by 5. And then graph it. Okay. The y-intercept of the line is 0, 4. So I can just trace it, and I see, oh, okay, look at the y-intercept is at 0 and 4. So it's not A. So I can eliminate A as an answer also. As the values of x increase, the values of y increase. That would mean it's a positive slope, right? As one's increasing, the other one's also increasing. I can see this as a negative slope because as x is increasing, the y values are decreasing. So the answer to this is C. It's not a multiple choice, multiple select test. It's just one correct answer. So I can stop there. I don't even have to really go to the fourth one. I could. The line intersects the x-axis at a positive value. Yeah, you can see that right there. So the answer is C. All right, next question. Jelani made a mistake solving an equation. His work is shown below. All right, I'll write it out and we can just kind of do it how Jelani does it. Maybe Jelani uses green pen. So I have 5x. What is a green pen? Okay. 5x minus 3 times the quantity of 2x minus 4, and that's all equal to 2x. So the way that Jelani started this, a lot of times I like to start with distributing to get rid of this, but that's not how Jelani started. Jelani started, it looks like, by getting rid of this 5x. So his first step, this is like step 1. And going to step 2, it looks like he subtracted this 5x. And to keep it balanced, he must do the same thing there. So if I did that, that would leave us with negative 3 times 2x minus 4 equals 2x minus 5x is negative 3x. And that's, all right, this is really number 2 right there. Okay, so that's that seems to make sense. So step 2 looks like not a problem. His next step, it looks like he decided to distribute this negative 3 to get rid of this parentheses. So negative 3, when I say distribute, I'm going to have to take this, all of it, and multiply times everything inside here. So negative 3 times 2x is negative 6x. Negative 3 times negative 4 is positive 12. That all equals negative 3x. So if I look, we've already caught Jelani's mistake. I can stop, right? This is a good test-taking strategy. I don't have to keep going and solve it, just, oh, I'm pretty sure that I did this correct. That's not what Jelani did. So it looks like he made the mistake going from step 2 to step 3, which is B. All right, next question, number 6. Okay, the table below shows the total cost of parking a car in a downtown garage for different lengths of time. From 1 to 3 hours, it goes from 22 to 30. This looks like a linear function to me. I can check in a second. Which of the following statements represents the rate of change? When I think of rate of change, I'm thinking of slope of the line containing the data in the table. So from like here to here, it goes up $8. And this goes up plus 2 hours. So like the change in cost. Change in cost, if this is y, that's x, or the change in x is 8 divided by 2, that's 4 to 1 if I simplified it. So if you think about it, what is that $4? That's $4 for every 1 hour of increase. So that's the cost. The total cost of parking. In other words, this is the cost of parking per hour. Easy enough. 7. The zeros of the function. So right away with zeros of a function, excuse me, that's some good tea. Excuse me. Hold on, it's really good. Okay, the zeros of the function. F of x equals -7 times x plus 2 times 5x minus 15. When they say zeros of a function, they're looking, I know this is going to open down because this is negative. So, right, if I have my parabola, it looks like this. They're looking for these points. These are the zeros, or the roots, or the solutions. These are all words that mean the same thing. The calculator is great for stuff like this. I could go through and factor it, or I can use a quadratic formula. I don't need any of that. I'm just gonna move this aside here. Let's see if this works. Okay, try my calculator. I'm gonna clear out the last one. And when they say f of x, if you don't like thinking in terms of f of x, just think of f of x as y. So I'm just gonna enter it just the way it's written, -7 x plus 2 times 5x minus 15. Perfect. And I'm gonna graph it. Okay. So I can trace it and, all right, let's try to find a 0. I can hit second and then the trace button, and I'm gonna go to 0. And it says left bound. So left bound means I have this cursor. Where's my cursor at? Where'd you go, cursor? Oops. There you go. There's my cursor. So left bound means I want to put it on the left side of the 0, and right bound means the right side there. So if I hit left bound here, right, this is on the left side of the 0, because this parabola is kind of going up and down here. But I see, and the right bound, I'm going to move it to the other side. And when it says guesses, hit enter. Oh, there's my 0. 3 and 0. And that could do the same thing for the other side, or you could probably just see that it's, that's just -2. So this has zeros at -2 and 3. So my zeros, so this is one that takes 30 seconds. There you go. -2 and 3. Perfect. In the expansion, number 8. Let's see, I'll use brown for this one. In the expansion of 2x squared minus 3x minus 1 times x plus 5, what is the coefficient of x squared? So this is one of these. There's a lot on this test that if you just slow down for a minute and try to think, okay, what are they really asking? It's not so tough. Okay. So when they say expanded, this is like factored right now. I'm going to take it, I'm going to distribute this with this. All right, and there's a couple ways to do that, and I'll show you those in a second just to stay organized. But in the end, we're going to do that. We're going to clean it up, and they're looking for what the coefficient, what's the number in front of the x squared term. So a couple ways you can do this. You can do it with like an area model. Sorry if my writing's not so great, but something like this works. We've done this in Mr. Gerard's classes here for like expanding quadratics. Okay, so I have, if I take this one, I'll put this up and down here. This will be, so this is going to be like 1x. That's where this, I'll put a 1 there. 1x, and this is 5. Positive 5, if that helps you keep it straight. And then over here I have 2x squared, right, minus 3x. I could put a positive, that helps you, and minus 1. So essentially, the area of this rectangle here would be, right, the length times the width. Or I could also find the 6 smaller areas inside and add it together, which is what expanded form is. So like if I have x times 2x squared, that's going to be 2x cubed. And then I'll have 5 times 2x squared, that's 10x squared. 5 times negative 3x, that's negative 15x. 1x times negative 3x is negative 3x squared. 5 times negative 1, I mean, I can really stop here, but I'll continue just to do it, because I'm only really looking for these two here. But we'll go all the way through it. Negative 1 times 5 is negative 5. 1 times negative 1, or sorry, 1x times 1 is negative 1x. So at the end of the day, I'm going to start with, I'm going to have 2x cubed plus 10x squared minus 3x squared. Right, I have all this. I don't even really need it. I can just stop here because they're just looking for what this is, but let's just do all of it. Minus 15x minus 1x is minus 16x. And then minus 5. And then if I combine like terms, I get 2x cubed. 10x squared and negative 3x squared is plus 7x squared minus 16x minus 5. So this is what they say. When they say, oh, what's the coefficient of this extra term, they mean that. So that's one way you could have done it. Some people don't like doing the area models, which is fine. So you can draw arrows too. Just imagine taking, I'll do it in a different color. You're gonna take this number and you're gonna multiply it times everything in that parentheses. And you're gonna take this number and also multiply it times everything in the parentheses. So that marker's dying. There you go. So either one of those works. If you did this, you'd end up with these 6 terms and then same thing. 7x squared. So 7 is the answer. So that is B. That's good. All right. Cruising along. Not that one. All right. Too much paper. Okay. Number 9, find all values of x that satisfy the equation. Well, write your solutions in the shaded box. There's ways to do it. I don't know if your teacher covered it with you this year, but for this is another one that's just let the calculator do it. Okay. If I see something like this, something like that, set equal, if this is like a quadratic that's been set equal to 0, I'm just going to graph it. They're looking for the solutions, the roots. So I'm going to graph it and I'm going to find the x-intercepts. So let's just put it in, just like it's written, but instead of x plus 1 squared minus 25 ninths equals 0, I'm just going to set it equal to y. So I'm going to have x plus 1 squared minus, and I like to use a lot of parentheses in this thing just to keep it organized, minus 25 ninths. Now I'm going to graph it. Okay, so I can see it has 2 solutions. So I can calculate the 0 again. So left bound, I want to move this cursor, I don't know if you can see that cursor, just to the left side, right? I'm going to try to find this 0 first. Sorry, it's kind of shaded like that. There you go. Oops. So I'm going to hit left bound there, and then I'm going to move it down just to the other side of the x-intercept, hit right bound, and as for guess, just hit enter. Okay, my first 0 is negative 2, looks like negative 2 and 2/3 is the first one. And I'm going to do the same thing again, but this time I'm going to move the cursor to the other side. So left bound, the left side of it is here, right? And the right side of it, you hear my wife yelling at the dog, is there, hit enter, that is 2/3. Sorry. And for these, you don't even have to show your work. So when they say like, oops, my wife and the dog might be coming downstairs to join us. Okay, so negative 2 and 2/3 is really just negative 8/3 and 2/3. Super easy. Oh, say hey, Muffin.
Hey.
Hey, Bernie and Muffin, you're in an algebra video. Woof woof. Okay, number 10. If Sam works 8 hours per week, then his weekly income from his car repair business is 15H minus 100. Which of the following best describes the meaning of 15 in this expression? The number of hours he works per week. Well, that's not it because he works 8 hours per week, right? So go ahead and eliminate that. B. The amount of money he makes after he accounts for the cost to run his business. Nope. That's going to be whatever this is equal to, right? That's going to, so that's not this, right? Because like this expression is going to give you the amount of money he makes. The amount he earns each hour. Yes, right? Because it's this times the hours. So the answer is C. And D doesn't really even make sense. This is kind of easy peasy. Okay, bye, Muffin. Bye. Yeah. Yes, you're YouTube famous now, honey. All right, number 11. The temperature T in Fahrenheit is a function of altitude A in feet. It's modeled by a linear function. T equals negative 35 10,000ths A plus 60. Which of the following statements is the correct interpretation of the slope of the linear model? All right, so if you think about this for a sec, some of my kids, and a lot of us in general, for whatever reason, when it's not y's and x's. So if I have this, I have t equals negative 35 10,000ths. So how do I want to say it? 10,000ths a plus 60. I can change this to y's and x's. So t equals temp and a equals altitude. I'm going to change it to y equals, this makes some of us happier, 35, negative 35 10,000ths x plus 60. And I could think of like the temp as y. I've turned that into y, and the altitude as x. Okay. This might help this maybe make a little more sense. So I have a slope of negative 35 10,000ths. So this is a negative slope. If you think about a negative slope, right, I'm going to have something kind of like this. And a way to think about it is, these are my x values here on this axis. As my x values are increasing, my y values are decreasing. As x increases, y decreases. Or you could think the opposite way and say as y increases, x decreases, but one's increasing while the other's decreasing. So if I go back to our multiple choice question for a sec, and part of this test is being able to finish and like not getting bogged down in, right? We're not really looking for what the temperature is at certain altitudes, but let's think about the slope of this. So here's the slope. For each increase of some elevation, the temperature increase. Well, it can't be that because that would mean it's a positive slope, and this is clearly a negative slope. So it's definitely not that one, and it's also not this one, right? Because that also has a positive slope. So even if I just get to this point, right, I'm already at 50-50. So even if I'm going, okay, I'm going to start guessing. If there's 20 minutes left and I'm going to guess, I'm at a 50-50 instead of 1-4. So that doubles my likelihood of getting it correct. So let's think about it. So for every, we said this, for every one of these, for every one change in this, it's going to change this much. So for every one change in x, it's going to change this much. That's what a slope means, right? As this it goes over by 1, it's going to decrease by negative 35 10,000ths. So where do I see that? For every increase of 1 foot, it's going to decrease by this. So the answer is D. If you weren't sure, you could also try to graph it and see which one makes more sense. we made? It was 100. That was 10 thousandths. Man, I need glasses. Okay, so the answer is D. Next question. All right, we'll try to speed it up a little bit. If x minus 7 is one of the factors of 2x squared minus 11x plus k, what is the other factor? So they throw this in just to confuse you a bit, this plus k, but it doesn't really change much. I know I'm going to have to, when they say one of the factors, I'm going to have like x minus 7 times some other factor, right, to give me this, 2x squared minus 11x. I need 2x squared minus 11x plus some other constant, which we're not really worried about just yet. Okay. All of these have 2x in the factor, so I'm just going to go ahead and put that in because we know it's definitely that. Okay. I'm going to do this in maybe a couple different colors, and we'll see which one works. So if I started multiplying this, if I put the first one in, say negative 21, and then I distributed it, well, I'd have, right, 2x squared, if I did, times that, times this, times that, and times that. Okay, so x times 2x is 2x squared. X times negative 21 is negative 21x. Negative 7 times 2x is negative 14x, and then I'm going to have some constant term, negative 7 and negative, whatever this equals, negative, positive 147, right? We don't really care about this. Well, when I combine these, I'm going to get negative 35x. That's not what I want. I want to get negative 11x. Okay, so it's not A. And I'm not gonna eliminate B, but I'm gonna guess it's not B because that's gonna also probably be way off. So let's try, like, say C. So instead of 2x plus 21, I'm gonna do the same thing, right? And then I'm gonna distribute it again. And you can distribute with the arrows. You can distribute with the area model. So I have x minus 7. I have 2x plus 3. So it gives me 2x squared in that box, 3x, 3 times negative 7, negative 21, I don't really care about that box, and negative 7 times 2x is negative 14x. Okay, that looks like that might be the winner. So I'm going to have 2x squared minus 14x plus 3x, oops, that's minus 11x. I don't care what this is just that k they were trying to confuse you with. That's what I wanted. So it's got to be this one, 2x plus 3. So the answer is C. Okay. This next question is another one of those questions where if you stop and I think, okay, well, what are they asking? How can I solve it? It's not so bad. Given h of x equals 2x cubed plus x squared plus 7, what's the value of h of negative 3? Excuse me. This is another one where how should you do this? I mean, I could plug this in. I could definitely do this here if I want, or I can use the calculator. If you haven't bought a calculator yet, you should. You'll use it forever. Okay, 2x, move this here so I can see. So I'm just going to enter it just like they have it. 2x to the power of 3. Can you see that okay? 2x cubed. And I'll put that in parentheses. Plus x squared plus 7. And I'm going to graph it. Ooh, that's an interesting function. Okay. All I'm looking for is, when they say h of negative 3, what that means is, when I input negative 3 into my function, what's the output? That's what this notation here means, right? When they say that parentheses with the h of negative 3, they're saying, put that into your function for x and evaluate and tell us what the output is. Okay, so With the calculator, a good way to do this is to use the table. So if I hit second graph, a table pops up, and then I can just go to that x value. Oh look, x is -3. That looks to me like -38. There's your answer. -38. Easy peasy. You could also input that and evaluate it that way. This doesn't, you don't have to show your work here. So just let the calculator do it. Okay, 14. Naoki has 50 CDs. She joins a club that sends her 3 CDs a month. Which of the following, you guys probably don't even know what CDs are, I bet. I bet you probably never even used a CD. She joins a club that sends her 3 CDs each month. Which of the following equations express the numbers of CDs, blah blah blah, in Naoki's collection as a function of the number of months after she joins? Okay, so for any linear function, I need to know the slope and the y-intercept. The y-intercept is where I'm starting, and the slope is how it's changing. So I see this, I think, oh, that must be the slope, right? It's changing. Sorry, it's sloppy. Slope. So that's how it's changing each month. So for each 1 month, it changes by 3 CDs. This is like the change in y. And this is the change in x. So this is the slope. And she has 50 CDs to start. Okay. This tells me that she just gets, this first one, that she gets 3 CDs a month. This one tells me she gets 50 CDs a month. This tells me she starts at 3 CDs and gets 1 CD a month. So it's this. She has 50 and she gets 3 a month. Boom, easy. If you're not sure, you could also just graph it, right? Maybe a table is a good way. If I think of like months and CDs, tables are a great way to help you on this test. Okay, 0 months, she has 50, and it's just increasing like this, right? So if this makes sense to us, well, I can just put that in a calculator, and I can use the table function again. Okay, y equals 50 plus 3x. Graph it. It's not on there because it's starting all the way up at 50, but I can still use the table. Okay, that looks a lot like what we just talked about, right? Starting at 50, going up, 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 up by 3 each month. Very topical CD stuff. Kids love them. All right, next question. The graph of linear function f of x is shown below. So okay, there's f of x. Another function g of x has the equation g of x equals -3/2 x plus 13. For what values of x does f of x equals g of x? Okay, there's a couple ways you could do this. I'm going to graph it. I'm going to use the calculator first because I think that's probably the easiest way to do it. What is f of x? Well, this is just a horizontal line at 4. So this is really just the line like y equals 4 or f of x equals 4. And g of x equals -3/2 x plus 13. You know, I'll do this with the marker. Okay. And I said, if you don't like writing in function notation, just think of it as, right, I said there's a line at y equals 4. And this is like our first equation. And our second equation is g of x, which is just y equals -3/2 x plus 13. Okay. I can solve this with the calculator. So, excuse me, I'll do that first. Okay. So our first equation is just y equals 4. Our next equation is y equals -3/2 x plus 13. Can you see that all right? All right, there you go. So I have a system of equations. Now let's use the calculator. Second, calculate. I want to find the intersection. I think you just hit enter, 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 and it should pop out the answer. There you go. 6 and 4. So for what value of x does f of x equals g of x? Well, the answer right here is 6. I could have also set this up as like a substitution problem. And okay, I want to find the point where they're equal to each other and just set them equal to solve it, like 4 equals negative 3 halves x plus 13, and solved it for this. And I should also get this, but to me the calculator is the way to do that one. All right, a line passes through 2 points. I'll go back to the okay. A line passes through 2 points, 0 and negative 2, and 9, 1. So I told you, right, a good way to, if you're not sure, to organize your thoughts is a table. And it's going to go through 0 and negative 2, and 9, and 1. What is the y coordinate of the point on this line whose x coordinate is 12? So they're essentially, so this is an element. If you just stop and think for a second, what are they asking? What is the y coordinate? So they're just asking for, okay, well, when it's this, what is this equal? All right, well, if it's me, the way I'm going to do it is I'm going to write a function. I'm going to write a linear function, and I'm going to input this to get this. So to write a linear function, remember, it's going to be like y equals the slope, which we call m, times x, plus the y-intercept. A lot of these, they don't even give you the y-intercept. Right, you got to kind of work backwards and find it. This one gives it to you. So I have it right here. 0 and negative 2, that's the y-intercept. Okay, so it's going to be something times x minus 2. There's the y-intercept. When x is 0, y is negative 2. Well, what's the slope? How's my y changing? Well, from here to here, that looks like that's going up 3. Right, that's the change in y. And from here to here, it's going up 9. If I simplify that, I get 1/3. So my equation is this: y equals 1/3 x minus 12. All right, so there's a couple ways we've learned to do this. I can input 12 into this, so you can write it in your head. 12/3 x is 4. 4 minus 2 is 2. So there's an answer. I could also just, I said, y equals 1/3 x minus 2. I'm just going to enter y equals 1/3 x. And to do a fraction, in here it's just a division symbol, right, with the parentheses. 1/3 x minus 2. Graph it. And if I want to input a number, I can just hit second, calculate value, 12. Oh, that's too big. It's not in the graph, so I can just go back to the table. There you go. When x is 12, y is 2. Just like our function told us. Easy. All right. So the answer was 2, which was C. Next question. Find all solutions of x squared plus 2x minus 3 equals 0. So this is just like we talked about earlier. Let the calculator do all this. So instead of saying equal to y, I'm just going to say that's, or to 0, I'm going to say that's y. So I'm going to say y equals x squared plus 2x minus 3. Graph it. All right, there you go. I can already see the solutions. So it looks like it crosses. I don't know if you can see if I do this. It looks like it crosses at positive 1 and negative 3. At positive 1 and negative 3. There's the solutions. That's literally like a 30-second question. It looks gnarly, but it isn't. Positive 1 and negative 3. Boom. All right, the next one's an inequality. But once again, not so tough if you slow down and think about it for a minute. Tickets for a high school play sell for $5. 700 tickets were sold in advance. The theater has 1,000 seats. So they've already sold, the tickets are all $5 a pop. And they've already sold 700 tickets. And they have 1,000 seats. So how much money have they made already? How much do they already have in the bank? Well, to me, that would just be the 700 times 5. So they've already got $3,500, right, that are sold already. They can sell up to 1,000 seats. So they could do, they got room for that much. So we're talking about the amount. Let A be the total amount of ticket sales in dollars. So we're not talking about the number of tickets. So let's go ahead and eliminate this. This 700 is talking about like the number of tickets, which still doesn't really make sense. This makes partial sense that they're going to sell an amount either greater than greater than or equal to 3,500 because they've got equal to this and they can only go up, right? They have a strict no refund policy at this place, so greater than this. And at a max, they can do equal or less than this, right? So like this is partially true and this is partially true, so it's this right here, right? A is less than or equal to 5,000 and greater than or equal to 3,500. 18 and C. So if you just kind of put that one out, not so bad again. 19. Ooh, 19 looks really gnarly, but it's pretty good. Given the graph below, which of the following gives the number of values of x, where f of x equals g of x? Okay, I'll do this. Sharpie. So when they say when f of x equals g of x, so f of x is, trace it in green maybe. Okay, there's f of x. Yeah. There's f of x. And I'll try the orange one, although it's dying. There's g of x. Well, you get the drift. There's g of x. Which of the following gives the, that's terrible. Let's come down there tomorrow. Okay. Which of the following is the number of values of x where f of x equals g of x? Okay, well, it looks like they're equal to each other there. There's one. And there. And there. And there. And there. And there. So how many numbers do they equal each other? It looks like 1, 2, 3, 4, 5, 6. So that's the amount of times the number of values. If they said, what's the, I don't know, that's a different question. We'll get into that later. Okay, easy. Next question. 20 is the big one. Construct a response answer. Soccer ball is kicked upward from the ground with a speed of 96 feet per second. Its height h in feet after t seconds given by the equation h of t equals negative 16t squared plus 96t. Okay. So I've told people if, well, let me write the function first. H of t equals negative 16t squared plus 96t. And if this throws you off, you can also think of it in terms of y's and x's. Just make sure you remember which one is which. So the height, right? The height, h of t is the y value, so like y equals the height. And the t, this is like the time in seconds, equals time. Okay. All right, so let me ask a couple questions. How long will it take for the soccer ball to return to the ground? So if you imagine in your head, I'm just going to sketch a part of it, right? There'd really be something that was kind of like this. But I'm not really concerned by this because we're not caught, right? We're just dealing with like the real world, which is a lot of stuff in this first quadrant. So it's going to be a parabola that opens downward like this. And it's going to keep going on and on and on. This way and down this way, something like this. There you go. The first question, how long will it take for the soccer ball to return so here's 0 seconds. This is like feet. This is the height. And this is the time. Sorry, this is height. This is how tall it is. And the time. So how long will it take for the soccer ball to return to the ground? So like, imagine here's Mr. Jordan kicking a soccer ball. He's punting a soccer ball. Goes up and it comes down. And it hits the ground right here. So the time it takes for the soccer ball to return to the ground is whatever this x value is. So for A, we're looking for the x-intercept. right? That makes sense. It's like, oh, it's this amount of time, right? How long? How long will it take the soccer ball to reach its maximum height? So we're saying like, when the ball gets to its maximum height, how many seconds was that? Like, what's the hang time or whatever you want to think of it as? So I'm looking, so for B, I'm looking for the x value at the max of the parabola. That makes sense, right? And then for C, what's the maximum height of the soccer ball? So they're looking for the y value, right? The height is measured by the y values. What's the height, the y value of max value? Okay. So once again, this is a perfect calculator question. So let me move, look at how, we'll come back to that in a second. All right. I'll take a couple books out so you can see a little more. Here's what Mr. Gerard's reading tonight. Noam Chomsky. Okay. Alright, so the first one. Y equals negative 16x squared plus 96x. Can I graph it? Okay. It's kind of hard to see. I'm going to zoom out so you can, zoom out, just hit enter again, just so you can kind of see the arc of this thing. I'm going to zoom out again. It's pretty steep. And I'll zoom back in a minute. Now, you can't really see it, but it's just like a very narrow parabola that just goes up and down. So I'm going to go back to the standard window. Okay. All right, so let's find the 0. Okay, so the first 0 is 0, 0, which, if you think about it, it makes sense, right? Because that's at like 0 seconds and then 0 feet. So 0, 1, the first 0 is 0, 0. There was no y-intercept here. So that makes sense. All right, let's find our second 0. This is going to answer our first question. So same thing, I'm going to hit second, calculate a 0. Or you know what, there might be even an easier way. I could probably see this looks like it lands at 1, 2, 3, 4, 5, 6 seconds, it looks like to me. So instead of that, let's hit second calculated value. I'm going to x is 6. Oh, that is it. Y is 0. There's our second 0. So how many seconds was it? It was 6 seconds to get back to 0 feet. So how long will it take for the soccer ball to 6 seconds. Perfect. How long will it take the soccer ball to reach its maximum height? Well, I can use the calculator and zoom out, and it's kind of hard to see on the calculator. If this is 0, 0, and this is 6 seconds, well, it would make sense that the maximum is going to happen halfway between these two. So if this was 6, this was 0, this should be 3. So that's at 3 seconds. So that's B. The x value at the max, how long will it take the soccer ball to reach its maximum height? 3 seconds. Okay. The maximum height of the soccer ball. I can use a calculator for this. They've made it kind of tough to do it. So, and I can't hit the value. I can't, because I can't see it. So it'll give me like an error message. Oh no, it does pop. Never mind. 144. There you go. So if I know it's 3, I can just hit a value, plug in the x in. I know it's 3. I'm looking for like when x is 3, when it's like 144. So it went 144 feet. That's one of the big ones. So that's like a long 10. Perfect. We're at like not even an hour and we're halfway done, and that's with all my talking. Okay. Next one. Piece of paper here. Okay. Next question. How many solutions does the following system of equations have? All right, so I have this. 3a plus b equals 12, and 12a plus 4b equals 48. So if it's in a variable you don't like, rewrite it with y's and x's. And it doesn't matter which one is which, as long as you're consistent. I could rewrite this as 3x plus y equals 12, and 12x Okay, so some of you might have already recognized, wow, this looks like this equation looks like this equation times 4, right? 3 times 4. Okay, so this is going to have an infinite amount of solutions. That's a bad I can say, but an infinite amount of solutions. If I wasn't sure, I could just solve this. So 3x plus y equals 12. Subtract 3x, subtract 3x. Y equals 12 minus 3x. There's one equation. And my second equation is 12x plus 4y equals 48. Subtract 12x, subtract 12x. 4y equals 48 minus 12x. Y divided by 4 equals 48 minus 12x fourths, and I can graph it and see. So essentially, like, how many points do they intersect? Parallel lines never intersect, so we say they have no solutions. There's no set of values that will make them both true. 48 minus 12x, all that divided by 4. Okay, so when I graph it, okay. So if I trace it, all right, there's my cursor. You can see, sorry, here's the function I'm measuring. If I use the side-to-side button there, trace, my cursor will give me some values, excuse me. If I hit the up arrow, it'll switch the function. Well, it looks like these are the same function. I could also go to the table and see, okay, when I have this x value, I have the same y value for all of them. They're the same function. They have an infinite amount of solutions. Perfect. All right. Oh, I know my students love these questions. A equals BC minus 2. And B does not equal 0. Which of the following equations expresses C in terms of B and A? So when they say expresses as C, or they say solve for something, that means I want to get it by itself. Sometimes they'll have multiple choice questions. I mean, this one's a little tougher because all of them are equal to C, but sometimes they'll have like A equals, so you can just eliminate it if it's not the thing that we're expressing for or solving for. But they all have that, so let's actually do it. Okay, so in the end of this, I want to have this by itself. So if you think about like doing the same thing to both sides, I'm going to add 2 to both sides. And I'm going to do that here. So I would have A plus 2 equals B times C. This is actually just like a 2-stepper. I'm going to then divide by B. Divide by B. These B's would cancel. And here I'd have A plus 2 over B. C equals A plus 2 over B. D. So that's infinitely many. Boom. Okay. 23. Which of the following tables represent functions? So remember, a function is the idea that it takes an input and it produces an output. The real rule that you're going to remember is, in a function, every input has exactly one output. Okay? So x's are my inputs and y's are my outputs. Okay, so if you think about this, in this function, if I put 0 into my function, it's telling me my output is 5. If I input 1, I get negative 3, 2, and 8. Okay, well, the first time I input 0, I got 5. The second time I input 0, I got negative 3. So 0, if I think about graphing it, there's 0 and 5, 1, 2, 3, 4, 5, and there's 0 and negative 3. So this input of 0 has 2 outputs, not a function. How about table 2? 1 maps to 5, 6 to negative 1. Okay, well, 6 again has 2 different outputs, not a function. Okay, here's the classic like tricky move where all of these share an output. Well, that's okay. You can share an output, right? 7, 1. This, if you think about this is just a vertical line, or sorry, excuse me, a horizontal line at y equals 1. This is the function y equals 1. The way we could tell on a graph is if I graph it and I draw a vertical line through any point of it, it should touch in exactly one spot. It's called the vertical line test. And that's just checking to see that if every input has only one output. Here, right, this would have gone through twice. So that's why this was not a function. But this is a function. This is like a one they try to trick you with. How about this one? 18, 7, 6, 9. Yep, that's a function. If it's got 4 different inputs, there's no way of us telling if it's not a function. And then this final one. So, yep. And this final one. Okay, these share an output, so not a problem until you get to here. This 2 has 2 outputs, not a function. So it's 3 and 4. Easy, I told you. Easy. Okay. A bike shop owner. Soda water, I'll break. Oh, that's good. Okay. A bike shop owner bought 18 bicycles and 16 trikes for $4,100.10. He found he under ordered, so he placed another order for 12 bikes and 8 tricycles for $25.91. Find the price for an individual bicycle, individual tricycle. To find any variables used, show you. Okay. For my class, this might be different for other classes. We like to use X and Y. We find that the least confusing. So I'm going to say we have bicycles are going to be X and trikes, I don't know if that's how you spell it, is Y. There you go. Bikes are X, tricycles are Y. So he bought 18 bicycles. So 18 times the amount of bikes plus 16 trikes for $4,100.10. Okay, there's my first equation. So I placed another order for 12 more bicycles and 8 tricycles. And that guy cost $2,591.40. Find the price for an individual bicycle and individual tricycle. Okay, well, I've got my system. Now I can solve it. There's a couple ways you could solve this. You could solve it via elimination or combination, however you want to call it. Right, I could like double this times -2 and solve it. So I'll do that first. That'll be the first. Well, so defining our variables was this. Show your work. Okay, so a couple ways to do it. The first way I could do it is I'm going to take this whole equation and I'm going to multiply it times -2. All right, so that would give me -2 times 12x is 24x. -2 times 8y is -16y. -2 times 2591.40 is -5,182.80. I did that in my head. And I'm going to combine it with this. 18x plus 16y equals 41. There you go. So that's one way to do it. Take it, combine it, and see what you get. Okay, this is going to be 24x plus 18x. That's 42x. This is going to cancel the 0, which is why we did all that. And then I'm going to combine all this. So -5182.80 plus 41. Okay. Equals negative 1,082 and 70. pretty sure I made a mistake, so we will edit that one out.